video is introducing derivatives of trig limits from first principle. So just that reminder that if you do have a circle or a curve and you have a tangent line, the slope of the tangent line is the first derivative of the function that you're getting the tangent point of. Hopefully that made sense. If you do find this video helpful, please subscribe and please check out my calculus website that includes topics and links to videos, and hopefully it's just a nice organized format for you to take a look at to find a video to help you. So if you needed that reminder, here is our first derivative when you're looking at as the limit tend towards 0 of your function. So this is derived from the slope. It's essentially your rise over your run when you're making your run closer and closer to 0. So when you are done, it is your slope. So what we're going to look at is using the first principle to calculate the derivatives. Once we calculate them, then you have them memorized. And if you ever forget, you just do this and you'll get it again. So if I want to figure out the limit, the first derivative, I'm looking as h tends towards 0 of f of x plus h minus f of x all over h. So I can keep going here, the limit, and now I'm just going to plug this in as h tends towards 0 of sine of x plus h minus sine of x, and this is all over h. Now there are a few things I'll have to do, one being which this part right here, this is an identity. So I can replace that, so sine as our limit tends towards 0 of sine of x times cos of h plus sine of h times cos of x. So what I just wrote out here, that is the identity with sine of x plus h. I still have minus sine of x, and all of this is over h. So when I do this, I'm just going to make a bit of a switch, just in case we don't see it. So I'm just going to swap places with these two. So I have my limit as h tends towards 0 of sine of x times cos of h minus sine of x plus sine of h times cos of x all over h. Now, out of these first two terms, I'm essentially going to factor by grouping. I am going to take out a sine of x. So I'm still looking at my limit as h tends towards 0. So again, out of my first two terms, I'm taking out a sine of x. And when I do that, I'm left with cos of h minus 1. And then I still have that plus sine of h times cos of x. And this is all over h still. So what I want to notice here is this is one of our limits. This part, we've learned this in a different video, that this actually is one of our identities that will equal 0. So this first part is just sine of x essentially times 0, which just makes that term go away. And then we have plus sine of h times cos of x all over 0. So here, I'm sorry, not over 0. This part equals 0. This is also still going to be over h. So just in terms of the math, this whole fraction is over h. This whole fraction would be over h. So if I add this on, and because I'm multiplying, I can see that this part is one of our other identities that equal 1. I'm not sure why that all went away. So now that I have that, I would see that f prime, or my first derivative of sine of x, is just going to equal cos of x, because everything else either canceled out or equaled 1, and that's what I'm left with. So one of the first things I want to remember is if f of x equals sine of x, then the first derivative will equal cos of x. So again, this is something to remember, but if you forget, just use the first principle to figure it out once more. So our next one is to take a look at the cos of x derivative. So we're going to do the same thing. So to find f prime, I'm looking as my limit tends to 0. H will tend to 0. And I'm plugging in x plus h plus, or sorry, that's supposed to be minus cos of x. Right, so just looking at that first principle. Then I will expand what I can. So just like last time, there is an identity that lets us expand that out. So as my limit tends towards 0, I will have cos of x times cos of h minus sine of x times sine of h. And then I still have this last part here, minus cos of x. So with the identities, you should have a formula sheet, so you don't have to have the identities memorized, just recognize how to use them. So I have all of this work here, and same thing, I'm just going to rearrange a little bit. So I want to keep my limit as h tends to 0, but I'm going to swap these two once again. So I have the cos of x times the cos of h minus the cos of x minus the sine of x times the sine of h. So I'm not changing anything here. I am just rearranging the numerator. Now I can simplify. I can take out a common factor. If I factor by grouping, I have the limit as h tends to 0 of the cos of x times, taking that out, the cos of h minus 1. And then I still have the sine of x times sine of h all over h. So what I'm going to recognize once again is that if I separate each term over h, that this first part here will equal 0, and on the other side, the sine of h over h will equal 1. So I am left here with the limit as h tends to 0. So from that first term, it's just of cos of x, but we're multiplying it by 0 because we want to remember that this identity here equals 0. And then from my second term, sorry about that, I have minus sine of x, but the other part just equaled 1. So when I'm done, my limit, if my term is f of x equals cos of x, then my first derivative simplifies to negative sine x. Okay, so that is our derivative of cos of x. Because that term goes away. So once again, this is one that you want to remember. You're going to use it a lot, so you'll have it memorized. But if you ever forget it, you can just use the first principle. Now, the very last one we're going to take a look at is finding the derivative of tan of x. So we can remember that tan of x, so just rewrite it, is going to equal sine of x over cos of x. So this is taking into account that you know the quotient rule. So we have to, for this one, just make a reminder, use the quotient rule. Well, this doesn't want to write right now, so how come? Here we go. Oh, there we go. Now it shows up. Okay, so we're using the quotient rule, and the quotient rule, when we're looking at the first derivative, is going to be, so I'm just going to write it out here, f of prime of x is going to be g of x times f prime of x minus f of x times g prime of x all over g of x, and this would be squared. So this is if the numerator is essentially f of x and the denominator is g of x. So using that, we're going to start filling some things in. So f prime of x, so I'm going to take the term in my denominator, so cos of x, and I'm going to multiply it by the derivative of my numerator. And we've seen that the derivative of sine of x is cos of x. Then I'm going to subtract my numerator, which is sine of x, and multiply it by the derivative of my denominator, and that will give you negative sine of x. Now then, this is all divided by the cos of x, the denominator, that's an s, and this needs to be squared. Now we have all of that, so we can start to simplify a little bit. So here, if we have a negative times a negative, we know that will become a positive. So this simplifies to cos squared x plus sine squared x all over cos squared x. Now, the numerator is actually an identity, and cos squared x plus sine squared x is 1. And the denominator we can't do anything with. So that's still a cos of x squared. But that is actually what secant squared x equals. So that's what we have. So this last one that you want to remember is if you're looking at the derivative of just tan of x, then it will equal secant squared x. But if you forget, just plug it back in, use the quotient rule, and you can find it. So up next, we are going to start practicing with those trig derivatives using the product rule, the quotient rule, the power rule, all of that. But these three main derivatives you definitely want to have memorized. And as mentioned at the beginning, if you found this helpful, please subscribe. Take a look at the website based on calculus to see if there's any other videos that can help you. And if you're in chemistry, I do have one for chem as well. So a website that you often will see those videos also on my channel. Thank you as always for watching. If there's anything I can do for you, please leave me a comment. Thanks.